All right, welcome back. In this video, what we're going to do is we're going to talk about a technique for controlling devices called pulse width modulation. Pulse width modulation is where you change the duty cycle of a square wave that you're controlling something like a motor with, and with a very low duty cycle. In other words, when it's on for a short length of time and off for a long length of time, there's less energy delivered to the motor in terms of voltage and current and power, and it turns slowly. If the duty cycle is higher, it turns faster. And this is how you can control the speed of something or the brightness of an LED. I don't have a motor and motor controller right now, so I'm going to show you this with an LED, and I'm also going to show you to it on the oscilloscope so that you can see how the pulse changes. I've written a little bit of code here already. It's a very simple program. I didn't feel like just typing it out while I was talking to you, and I also wanted to make sure it worked properly before I presented it. So I'm just going to go over the code real quickly, and then we'll show it to you on the oscilloscope, and show you the LED changing intensity as the pulse width changes. So it's a very simple program. It's basically, well, here's our CMake list.txt. It's pretty standard. We've seen these before. I'm going to be doing some other stuff later, so I just went ahead and included the boost libraries, but all we're really doing here is finding the PWM package, which we've looked at before. This is how we control our GPIO, or general purpose IO system. And then, of course, in the directory where we've got our code, we're just adding an executable and adding that PWM in as the target link library. So that's very straightforward. All the source code will be up on GitHub, and the link will be there to get to it. So if you want to take a closer look at that. So let's go back to our SIGGEN. When the program starts up, we've got an integer here, which is going to be our frequency, and the usage of this is you're going to run the program and supply the frequency. The frequency is the frequency at which our signal is going to be, and that's going to be fixed during the run of the program. And what we're going to be changing then is that pulse width on that particular frequency. So the beginning of this is just, pulling that data in, so I get that argument in to a string stream here, and then punch it out to that frequency value, and that converts it from a string into an integer. Very simple way to do that. I'm not doing any error checking right here, but I'm the one that's using it, so I'm going to type in the number correctly. The only error that could occur is if you type something wonky, like put letters instead of numbers, then it won't be able to do this, and you'll get an error. So or you'll get some erroneous results. So what we're doing here with GPIO, in fact, let me do this real quick. What is it? Font. Editor font, zoom in. Let's make that a little bit bigger. I'll do it again so you can see this. I sometimes forget to do that, and I know on a screen it can be hard to see. So this call here, GPIO set PWM frequency, sets it to that frequency that we pass in. It sets up that pin 14 is what I'm using, and I've set up a little circuit here. I'm going to show you the circuit, and I'll show you the LED and stuff, and I'll also show you the scope. But I broke out pin 14 to use this. So the GPIO sets up the frequency that it's going to run at, and this sets up the range. And the range is the range of numbers that are going to be from 0 to the maximum value. In other words, fully on a DC full power signal, to 0, which is a 0-volt signal. And I probably should have indented this, and I didn't. So I'll just come down here, the for loop, put that in there. Where's the while? So this one actually goes back here. Oh, darn it, that one goes there. 4 and 4. Oh, I see. These two actually come out. We'll get this neatened up a little bit so it's a little easier to read. There, that looks better. Okay, so all I'm doing is creating a loop. It's a continuous loop. And what I do is I run it up from 10 so it doesn't completely shut off, up to 2000. and I sleep for a millisecond, so it takes about 2 seconds for it to get all the way up there, which is another reason I chose the 2000. And then it goes down from 2000 down to 10, and you'll see that on the scope. You'll see it doing that. This is just here when it's done. I don't actually need this because it's running continuously up there. I had that in there when this was running straight through before I put the while loop in. It was finishing and I wanted to leave the PWM signal on so I could look at it and examine it with the scope. So that's pretty straightforward. Let's build it. I'll type make here. Okay, and so now I'll run it. So all I'm doing here now, remember I told you when we're dealing with the GPIO, at least right now, there's some ways we can get around this. Right now we have to do this as root. Only root has access to the hardware. There's ways we can work around that so that a user account can gain access to it in an appropriate way. We'll do that later on. So right now I just have to run this from root. I'm running the program and passing in a frequency of 500, which is 500 hertz. That's what it's going to run at. So now you can see on the scope this square wave, and it's sweeping back and forth the end signal, the end of that square high rising square signals, right back and forth. This is the duty cycle that's changing. We're ramping it up and we're ramping it back down. And also here on the screen you can see the LED getting brighter and then getting dimmer as the goes down. And that's how that PWM works. And we're going to do this with some additional project work. We're going to build this up and do some different things. And eventually here I'm going to get some sort of small motor controller or make something that works reasonably well for a very small motor, something that will run on maybe 12 volts or something. And I think I've got a 12-volt power supply around here somewhere we can use to run that. So anyway, that's it for this video. It's PWM, and it's an interesting part of the Raspberry Pi. You can do a lot of things with PWM. Later we're also going to use some of the other features of PigPio and build up some interesting signals for doing different kinds of control things, sending out patterns of highs and lows using a little signal generator, and we'll be able to look at that on the scope too. So yep, that's it for this video. Thanks for watching. I hope you enjoyed it. If you liked it, hit that like button, and if you really liked it, hit that subscribe button, and I'll see you in the next video. Thanks for watching.